Hi everyone, my name is Vesna Kong and I'm the Senior Advisor in Data and Analytics for Ecologic. And welcome. Thank you for joining us today for this webinar as part of Greener Infrastructure Week. Before we begin, I'd like to acknowledge the traditional owners of the land of which we are meeting. And I pay my respects to the elders past and present and the elders of other Aboriginal communities who may be here today. Aboriginal and First Nations people have been caring for country for over 60,000 years. So I'd like to use this time to share the local Wurundjeri seasons of the Wurundjeri people of the Kulin Nation, which is the land that I'm calling in from today. Wurundjeri people celebrate 7 distinct seasons, with November being the Boath Guru or grass flowering season, where kookaburras can be heard making noise at dawn and dusk and marking out their territory. Our session today is about technology for material tracking. Technology and digital advancements are rapidly transforming industries across the globe. In this session, we'll explore 3 material tracking technologies and hear insights from organizations implementing them, including why they selected this technology, the role it plays, and how it transformed the way they operate. There will be an opportunity to ask questions through the Q&A function, so pop your questions in the Q&A section and we'll try to get to them by the end of the session. And now I'd like to introduce Dr. Reza Mohammed, who will be hosting today's session. Reza is from the Level Crossing Removal Project and leads the Hive, which is Australia's first innovation incubator on a major construction program where they connect and support people in exploring and trialing ideas to deliver breakthrough outcomes. So I'll hand it over to you now, Reza.
Thanks, Vesna, and good afternoon, colleagues. Vesna, maybe you could give me a thumbs up, or someone can give me a thumbs up, just to ensure that you can A, see me, and that you can B, hear me. Amazing, thank you. So my name's Reza. Thank you so much for the introduction, Vesna. I'm from Level Crossing Removal Project, and if you live in the state of Victoria, then there's a good chance that you live near to, or you take the train through, or drive past one of the 84 level crossings that we've removed. But the thing is, we do far more than just remove level crossings. We build new stations, we duplicate and extend rail lines, we build new facilities like bus depots and car parks, and so much more. And I think at the core of our approach to the way we work is innovation. So I'm from the Hive, as Vesna mentioned, and we're the LXRP's Improvement and Innovation Program. And my colleagues and I, we explore project improvements and innovations, how they might be developed, trialed, funded, and operationalized. We have 3 connected Hive teams that are dedicated to improving the way that we deliver our projects. And we're here to support you to explore and develop your improvement ideas. So I guess it's an ask of a call to action to please reach out to us and let's explore and discuss how we might be able to collaborate. Another thing that we do is we expose our people to the latest and greatest innovation approaches and new technologies through a series of events that we've called Innovation Bites. And we spell that B-Y-T-E-S. It's a play on words, in that oftentimes bites as in it's technology related, bites as in it's bite-sized, and bites oftentimes because we have it over lunchtime. So in bite-sized chunks, we converse, we share, we connect, we're inspired, and we're motivated to ask, what if, or why not? And we've heard from companies like Procter & Gamble, Bosch, NASA, Boston Dynamics, Coca-Cola, to name a few. So we're really humbled and pleased to have the opportunity to collaborate with Ecologic on today's session. And Vesna touched on what this session is about. And I want you to think, right? Like when you travel, you can track the apps on your phone that you can track the aircraft, its route, its height, its speed, and so on. When you order your Uber, you can tell where the taxi is, where the car is, how long it's going to be. And if you order your I don't know, your pineapple Domino's pizza using the app, you can see this little icon of a person on a scooter, and you can tell where your pizza is going to be, and it builds anticipation. So we know the technology exists. But here's the thing. Cradle-to-grave tracking of material on construction sites is by exception rather than the norm. And today we'll hear about some of these exceptions. We'll challenge the assumption that they are indeed exceptions. We'll explore the roadblocks and the takeaways and the key learnings. So we're going to hear from 3 presenters from different but related fields. They'll each present for 10 minutes. And in 30 minutes time, we'll convene a panel discussion that will be powered by you. So we want you to please keep adding your questions to the chat or the Q&A, and I will ask them on your behalf. Now, our first presenter is Ella Walter-Pavlou. Ella, if you are there.
Hi, everyone. Thank you for having me.
It's great to have you, Ella. How are you?
Doing well today. Thank you. Yeah.
Amazing. Now, for those joining us at home and from work, Ella is Director of PropTech or Property Technology at JLL. And she supports clients with their technology strategies, including using technology as a tool to deliver smart and sustainable buildings, enhancing tenant experience, and improving process efficiency. And previously, Ella worked as innovation manager at GPE, a FTSE 250 property developer in London, as in the UK, driving innovation strategy and implementation of property and construction technology across GPE's portfolio. And then prior to that, Ella worked on new ventures for Swire Properties, leading tech strategy for the office and hotel portfolios across Hong Kong and China. So, wow, that's super impressive, Ella, I gotta say. And I'm also really curious. So you have worked all over the world, right? Hong Kong, China, UK, Australia. What's your impression of technology adoption there compared to Australia?
Yeah, good question. Look, I think there's a similar appetite and enthusiasm for tech adoption across all the countries I've worked in. So I can't give a clear winner in that sense. But I think that the constraints in those different countries are very different, and therefore the types of technologies that do well are very different. So I guess constraints around legislation, and which can limit or expand what technology you can implement, are quite different. So for example, in China, there's very different legislation around data privacy, facial recognition, that kind of thing. Yeah, which gives you more opportunity to deploy certain technologies, like, for example, maybe AI for security, something like that. But then equally, I think which technologies are well adopted by people and organizations varies a lot culturally as well, depending on the cultural instance. Yeah, so it's not a simple answer, but it's been very interesting for me to observe what works and what doesn't in different cultural contexts.
Oh, that's fascinating. Thanks for sharing, Ella. And I think that you might touch on some of these things in your presentation through some case studies. So I see you have shared your first slide, and I can see it. So whenever you're ready, over to you. And I'll see you in 10 minutes and then 20 minutes after that. Thank you.
Thanks, Reza. I appreciate the kind introduction. So good afternoon, everyone. I'm Ella Walter-Pavlou, as Reza kindly introduced me, and I'm excited to share with you today a commercial property perspective on material tracking, particularly with a view to material reuse as well, because I think that's one of the most, the greatest opportunities for material tracking. So I'm going to take you on a bit of a whistle-stop tour, lots to cover today around the problems that I've faced with tech for material tracking, a couple of success stories, and then some specific technologies that have been working well in playing a role to solve these problems. So first up, I wanted to, I guess, really dig into why we're still using so many new materials in construction, and what is really the challenge of material tracking for reuse. And so I want to share a bit of a story. So a couple of years ago, I was in London at this conference, which is Digital Construction Week in the UK. And it's a big exhibition hall. It was filled with the brightest minds who were the most innovative in terms of digital construction, really looking at, how we can digitize construction better, how we can look to more sustainable construction methods. And when I was in a discussion up on stage, we touched on material reuse, and I shared with the room that, you know, I really had a dream that one day we would get to a point, and in my mind it was quite simple, that we would have some kind of eBay for construction materials, right? A place where people who were demolishing buildings or sites could list materials that they had available and could be matched up with those who had a need for construction materials. Now, obviously, I knew it wasn't quite as simple as that. I know it's a complex problem and a complex thing to achieve, but I'm an optimist, and I did really want to speak to other people who shared the same vision and see if we could collaborate to try to make something happen. Now, unfortunately, when I shared this on stage, I actually got a lot of pushback. So I had a lot of people from the audience put their hand up. I'm talking like people who have decades more in the industry than me, putting up their hand and coming up with reasons why that couldn't happen or wouldn't work. So I was told, look, Ella, there's a lack of information. We don't know exactly how much of which materials are where. So it's just not possible. They were telling me, look, there's so many logistics and storage challenges. Supply and demand of different projects don't line up perfectly. And where are we going to store all these materials you're talking about when they're in between projects? And finally, some people were just very upfront and blunt and saying, look, it's cheaper and easier to buy new materials. So why would we bother to go to all of the effort? And as you can imagine, this made me quite disheartened, and it really wasn't the outcome I was looking for. So since then, I have really been keeping my eye out around success stories for material reuse and the role that technology plays in these. And I wanted to share with you a couple of these success stories today. So at that time, when I was speaking at that conference, I was working for a company called GPE, which is a property developer that does office buildings in central London. And there was a project going on where there was a great example of material reuse. So this is a building called 2 Aldermanbury Square, and it was being demolished, and all of the steel from that building was being reused in this new project called French Railways House. So just to help you picture the scene, French Railways House is on a street called Jermyn Street, which is about 1 street back from Piccadilly Circus. So it's in that kind of old London area, beautiful buildings, and, you know, really focus on design and how things can blend in well with the existing environment. And the steel reused in French Railways House was actually 1,000 tons of steel, which meant that the team saved 99% of carbon emissions compared to using new steel, which was an amazing result. And then maybe a more recent example, and from Australia, from the company I'm working for at the moment, JLL. JLL is less close to the construction of big buildings and big projects, but closer rather on the project side to refurbs and fit outs, that kind of smaller scale level of projects. So the team were working on a Department of Defence project in Western Australia, and were able to reuse various different materials, including switchboard and also various different fixtures and fittings in there. And I think the thing with these examples is that when I've been keeping my eye out for great success stories of material reuse, actually a lot of the examples have been driven by people, very enthusiastic people who are motivated to reuse materials, rather than driven by technology, actually. Although I see a lot of opportunity for technology to be involved in this process, I think because material tracking technology is really mainly being adopted in the last 5, maybe 10 years for the more innovative companies, it means that with the development cycle, there hasn't been much opportunity to find reuse from the projects that have used material tracking. So there hasn't actually been much tech involved in the great projects that I've seen. However, there has been a big involvement of people. The other thing that's contributed to the success of these projects was timing and location matching up, right? So removing that issue of logistics and storage by having projects that were well matched. And then finally, I did want to speak a bit about incentives. So not for the JLL case, but for the GPE case, there's a very innovative incentive that the organization had in place. So there's actually an internal self-tax on carbon. So all embodied carbon that goes into projects is actually taxed. So that basically means that the projects team have an increase to their bottom line depending on how much embodied carbon they're using. And this means that it helps align the project's team's incentives with the sustainability team's incentives and the overall goals of the organization. So that's why when it came to reusing that steel that saved 99% of emissions compared to new materials, the project's team were really motivated to find a way to do that. So as I said, there's not heaps around technology in those examples, but I have seen a lot of green shoots and a lot of exciting new opportunities with new technology that is helping in this space that I've worked with over the last few years. So first up, when it comes to, I think the role that tech plays in this space is really a really obvious win for technology is around data collection and gathering, and really having the right data about what materials are in which location, in which building. So there's a company called Qflow, which was originally set up to help with accurate carbon accounting in embodied carbon calculation in buildings. So this is a super simple solution whereby the on-site team takes a photo of delivery tickets to site and then waste tickets taken away from site to calculate the embodied carbon, not based on what was estimated by your surveyor, but rather based on what was actually used in the project. And although this was originally set up to be used more for that carbon calculation perspective and also verifying waste diversion rates as well, it has big applications for material passports, material tracking and material reuse as well. Another technology that's will be quite impactful in this space is digital twins. So digital twins, by which I mean taking the building information model or the BIM model from a construction project and actually using that model while the building is operational. So using it in a live environment, which is typically used more for predictive maintenance of plant and equipment. With more companies using digital twins for the operational life cycle of a building, it means that there will be more opportunities to reuse plant and equipment because we'll have a lot more accurate data around performance and quality and condition of plant and equipment. I did want to include an Australian startup in my tech companies roundup here. So MatTrack is a great example of an Aussie company which was designed for material tracking more for logistics purposes originally, but have now adapted with some really cool features to help with material reuse. And they're working with a large builder in China across 100 different projects working on their steel reuse. And I think when speaking with them, that really brought home to me, I think there's a big opportunity when you've got companies that have a very large scale for that reuse within a company. So then you don't necessarily need that marketplace solution that you would need for smaller companies to trade between themselves. And then finally, my last tech company I wanted to draw out is a great US-based company called Tangible Materials. And they're really a database for materials to help people make better material selection decisions. And I think this later down the line comes around for material reuse as well. So I'm running up to the end of my time here today, but while I see a lot of tech solutions that are playing part of the, solving part of the problem, I think it always does come back to people. And, tech can provide us with the data and perhaps the exchange platform for material reuse, but we really need people to collaborate across the industry to solve this problem. So going back to my dream of an eBay for construction materials, when I was at Digital Construction Week, although I had mostly pushback from people explaining to me why this wouldn't be possible, I did also have a few people contact me afterwards who wanted to collaborate and work on these projects together, from tech companies, from engineering firms, and also from contractors as well. And I think we really do need a lot of cross-collaboration in the industry to achieve this. So finally, for anybody who's been distracted by their emails, a few key takeaways. How can we solve the material reuse problem? While we do have a lack of information, technology for material tracking and data gathering can help solve this. While there are logistical and storage challenges, marketplace technology and also government involvement can help with this. For government involvement, I always reference Amsterdam. Their hub model for timber reuse is a really great model. And for lack of incentives, I would just encourage people to not wait for external incentives, to try and lead the way and create your own, for example, with the GPE's self-carbon tax. So that's all from me. Thank you for your time, and I look forward to the discussion later.
Amazing. Thank you so much, Ella. Is there some function where we could do like a virtual round of applause for you? Because that was fascinating. And I think that 10 minutes goes by so quickly, and I only realized that the time went because I had a timer on my phone, because I think I have so many questions to ask. So I'm hoping that they come through via Q&A or the chat soon, and I'll ask them on your behalf, colleagues who are joining us from home and at work. Thank you so much, Ella. See you soon. I would like to invite our next presenter to join us. Patrick, are you there?
Hello, I'm here.
I can see you and I can hear you. How are you?
I'm very well, thank you.
Wonderful, thanks. And for colleagues joining us, Patrick Ilott is the founder and CEO of the boutique sustainability consultant Perspektiv, and that's Perspektiv with a K instead of a C, and I think it has a few different other letters in there, which you'll see soon. Now, Patrick is an environmental scientist by trade, and he's a renowned expert in sustainability with well over 20 years experience, successfully delivering advice to both the public and private sectors here in Australia and in the UK. Now, Patrick has led Persspektiv's growth across most of the Australian capital cities, and he's been developing expert and very well credentialed service-led teams in carbon and circularity, corporate ESG, and sustainable infrastructure that passionately live the Perspektiv mantra, which I quite like, by the way, about finding a better way for all their clients. So Patrick, now I see that Perspektiv was founded in 2017, which seems like a long time, but maybe it's not such a long time, 7 years ago. What have you and your clients' approach and attitudes to, how has it evolved? Your attitudes and approach to sustainability in the last 7 years? Been pretty static, or have you seen a lot of change?
Oh, there's been a great deal of change. From my early career to now, I think the main change is that sustainability professionals were kept at arm's length from the seats of power, if you like. They were respected as people, but not necessarily as influencers. And I'd say around 2017, 18, 19, 20, the tide really changed, and we're invited into the halls of power, whether that was a boardroom or a little bit higher up in the bureaucracy. So I feel like we're much more listened to now. And we often have a seat at the table where we didn't before. Not saying it's perfect, but things have improved greatly. And now there is a greater onus on us being effective as a collective. And I think we really need to put our best foot forward and mature as fast as we can through events like this, through sharing and empowering one another.
Yeah, thanks for that, Patrick. I think that's exactly what these sort of events about, where you have a coalition of the willing who are really keen to hear about the journey that you've been on, and build connections so that we can not just learn, but that we can also share. And I'm really curious to see what you have in store for us. So I will see you in, well, 20 minutes, but 10 minutes initially. Over to you.
All right. So yeah, great. Thanks for that introduction, Reza. Hello, everybody. Really pleased to be here. I'm coming in from Perth today, so 3 hours behind you. So you're probably just getting through your mid-afternoon lulls, most of you on the East Coast there. I'm talking about measuring progress with material circularity indicators. Yeah, let's get into it. Let's go. Just check the time. 12:24. I'll try and keep the time. And I'll try and make my slides move. There we go. Okay. When it comes to circularity, there are commitments out there, and I'm not sure people know what they mean, but this one is a classic, I think, in that you can go to the website there and see it. All of Australia's environment ministers want to achieve a circular economy by 2030. And so when I read this, I think, what exactly do they mean? When will we know that we have achieved a circular economy? What metrics relate to this? How do we prove it undeniably, or see how far we still have to go? So this gets me thinking about, right, we need to start thinking about quantification rather than just subjective or qualitative statements. when I look at the good work that's been done by Ecologic in Victoria, I see that we're on a kind of a maturity curve. When I look at the Recycle First policy as an example, I see words like optimise where appropriate. And having worked a lot in infrastructure, I've seen people use those sorts of words in contractual contexts, where they can optimise the outcome they want with regards to their margin. And we don't necessarily always get the best outcome, or we're a little slower than we need to be. Not to be too critical, I think this is a great place to start. And you can see there the bottom quote that I put in there. This has helped led to us beginning to get data through this kind of introduction, this kind of policy. And it's very much about where to from here now that we're beginning to become aware, and we're beginning to test what is optimal and what is appropriate. Just by way of contrast, we've got this commitment to be a circular economy by 2030. Qualitative, I would say. Here, another hot topic, carbon, a little bit more mature. We can see that there's quite quantitative targets, and it's very clear to see how we are tracking against those targets. I can read about it in the paper on any given day. That's where we need to go to with the circularity, I think. Okay, I don't want to lecture anybody about the principles of a circular economy. I trust the audience has heard of it before. If I was going to try and summarize it, I would say it's, I always think of this kind of perpetual motion machine, a machine that spins by itself with no inputs and no outputs. That's kind of the ideal thing we're looking for here. This model here on the screen is quite famous. It's from the Ellen MacArthur Foundation, and it says about all the different ways things can circulate, and you'd want minimal inputs on the top and minimal leakage at the bottom. If you're able to keep things in circulation, then you're heading towards circularity. Now, looking at that screen, it's quite busy, and therefore you think any quantitative analysis is going to be quite challenging too. Okay, next slide. Enter these new standards, and these haven't come out of thin air. There's been a lot of people doing a lot of work over a number of years, but it's consolidated into this 59,000 series that came out earlier this year. That is beginning to articulate for all of us right around the world how we might set about tackling the transition to a circular economy. The third standard in the series is, in particular, it's about measuring and assessing circularity of performance. So that one's particularly pertinent. You have to go and buy these, but they're not so expensive. But if you're going to buy one, I'd buy that one first. And when you look in there, what's the point of it? Well, it aims to standardize the process by which organizations collect data. Okay, we're heading down that quantitative path. Good. It provides a structured framework for setting boundaries, identifying indicators, consolidating them, aggregating them, and being able to determine circularity at any given level, whether that is the circularity of a rock through to the circularity of a major infrastructure project, through to the circularity of a whole economy. This enables us to set about that quantitative exercise. As far as standards go, it's not a bad read, I would say. Okay, just to give you a little bit of insight into what the standard says, it says that there are certain core things that need to be contemplated when you are talking about circularity. And they're the 5 there that I've listed in the table: resource inflows, resource outflows. They shouldn't be particularly foreign to any of us. We already ask questions quite often, I think, about where does this product come from, what's in it, and also when we're finished using it, where does it go? So those sorts of things we're reasonably familiar with and are in the habit of asking about already. We don't always necessarily ask about the energy that was involved in the production of that thing or in its use, or in its disposal, although you see that occurring more and more with under the carbon agenda. And same with water. And then the bottom one is about economic outputs, whether that's revenue or employment in relation to resource use. There's some ratios. So anyway, the point is those 5 indicators are the core circularity indicators, which the standard asks us to look at when we're contemplating an MCI, Material Circularity Index, for any given thing. The standard says some of them are mandatory and some are optional. Essentially, the top 2 are mandatory. When you get an MCI, without trying to get too down into the science here, I'm just looking at the time, I need to probably pick up the pace. 0 is a bad score and 1 is perfect. You can see there's an example of an MCI we've devised for a particular product that we're using on a project here in Western Australia. And you can see the assumptions that have led to its score. Okay, next one. Okay, so we've applied the standard a few times, and we've applied it to infrastructure projects. So in the case of an unnamed infrastructure project, we can say, okay, it's going to be built, it's going to be a 10-year build, 50 years of operation. Let's look at the life cycle. Let's look at all the inputs that come in that phase. In relation to those inputs, let's understand what happens to their recycled content and their recyclability. Speaking in shorthand here, let's look at the volumes of those things. Let's work out an MCI for each of those. And we've done that using our knowledge of the market, of the products in the market. This is about a hypothetical future project. Apply MCI scores to those, and then let's aggregate that and get a picture of the circularity of an entire project. Now, this is an example of the outputs that come from such an exercise. We're able to say, okay, given the tonnage and the MCI of the various inputs and their likely end of life use, here are the impacts pie charted, which is actually, who doesn't love a pie chart, but pie charts are super useful. It tells us where the hotspots are. So on this hypothetical project, we have big impact here around the rock, the aggregates, the asphalt. We're also able to establish a score for the project overall. So it's about halfway down the spectrum, and we're able to get a quantity-weighted material circularity indicator. So we're getting to that quantitative point. Just checking the time, I will wrap up quickly here, Reza. With this kind of intelligence, we're able to spell out really targeted things we want people to do, like contractors, like designers. We can tell them, hey, we're currently here, we want you to get there. We want X amount of improvement over the coming period. And this is an example of some targets that are written up for aggregates, saying, between 2025 and 2035, we want you to lift the recycled content to 70% on our aggregates. And we know where they're starting from. That is a kind of a step change, I would say, from optimise and where appropriate. It's also enabled us to get much more strategic about how we remove barriers. We can make sure our training and awareness is targeted around those hotspots. Same with the engagement and the assurance. We can engage with those suppliers of those things to give us EPDs and the like, or to adapt their data collection. And we can mandate things through procurement. Now, I'm very conscious I've used up the time, Reza, so I'm going to stop talking and just leave that one there on the screen for a moment. We can also look at synergies between carbon and circularity. We can plot these things. Now, back to you.
No, thanks, Patrick. No, I think you can't leave us hanging. I see a matrix. I see 4 quadrants. What are we looking at?
Now, that is just the comparison of impacts by material category that compares their MCIs to their carbon footprints. And in the top right there, we've got things that have both that are both linear and high carbon, and therefore should be priorities to address first. So that's our quantitative analysis has led us to there on this hypothetical project. And yeah, we now know our priorities. Let's focus our effort on those things.
Amazing. Yeah, thanks for clarifying that. So there's method to the madness, and there's an approach that you use. And we're keen to hear more when we convene again in the panel discussion in 10 or 11 minutes. So thank you very much, Patrick.
Great, thank you.
And colleagues online, please continue to add your questions to the chat whilst we introduce our next speaker. If Paul, if you're there, please join us.
Hello everyone.
Hi, Paul. Yep, I can see you and hear you. How are you?
I'm very well, thank you, Reza.
Excellent. And for colleagues joining us, Dr. Paul Reichl leads the R&D, which is research and development team at Level Crossing Removal Project. Now, he is an expert in driving innovation across sectors such as technology startups, transportation, university research, infrastructure, and government. He has successfully led projects focused on sustainable, scalable outcomes and has extensive experience implementing IoT or Internet of Things solutions, advanced data capture systems, and conducting research in machine learning, photogrammetry, and MEMS. I'm not sure, is that MEMS? Maybe Paul will tell us what MEMS means. Paul has held key leadership roles in research and innovation programs. And Note 12, get this, this is super impressive. Paul is a co-inventor on 27 US patents. And on top of that, he holds a PhD in mechanical engineering from Monash University. Wow, Paul, incredibly impressive. Maybe first question is, what's MEMS or MEMS?
It is MEMS, Micro Electromechanical Systems.
Excellent. Thank you.
Acronym for.
And if there was a way, if anyone could let us know in the chat if they knew what that is, please enlighten me and put that in context. That'd be great. Now, Paul, I do want to ask you a question. You have a variety of experience. So you've worked in tertiary ed, the university sector, as well as a startup. And like, what can we in state government learn from both about an approach to problem solving? What have you learned?
I think one of the, probably a good answer to that is almost like, don't let perfect be the enemy of good. You know, get out there and try things, understand the space you're operating in, sort of iterate and learn things as fast as you can, and failing fast is the old sort of adage, but it is understanding the space you're in, because if you worry too much, and obviously in government, getting things off the ground can take quite a lot of time and effort. You try and get things perfect. Sometimes it's just get out there and learn as fast as you can and worry about refining it later once you're in a much better position to understand the space you're working in.
Excellent, thanks. So it sounds like trying to avoid paralysis by analysis then.
Yes.
No, I don't want to be paralyzed and take up too much of time, so I'm going to disappear. And Paul, I will see you in 10 minutes' time. Keen to hear what you have to say.
All right. Thank you, Reza. Thank you, everyone. So look, today I'll be talking, I guess, more about a couple of examples of projects that we've done in this space where we have used, I guess, computer vision and AI in construction projects to track materials and activity. And what do I mean by computer vision and AI? Well, in simple terms, it's essentially giving the computer an ability to understand pictures and videos, and AI is essentially your smart assistant that lets you sort of draw inferences from that. So you're sort of giving eyes to AI. I will just quickly run through some of the examples that we've sort of done in this space, but obviously data is now the driving force behind innovation, and it's often the key to unlocking the power of AI. And as I'm sure everyone's aware, AI has come ahead in leaps and bounds in the last sort of 12 to 24 months with the introduction of a whole host of large language models such as ChatGPT and the like, and the expansion of new AI and ML machine learning models on sites such as Hugging Face, where there's new models that can look at a whole range of things sort of popping up daily. However, unlike in many other sectors, getting efficient, generalized, reliable, and accurate source of data isn't easy to come by in construction. And as an example of that, I'll sort of cover off, I guess, give you an example of how data is often recorded now. In this case, we're looking at part of the spoil monitoring process. So what do I mean by spoil? That's essentially another or a fancier name for dirt. But how that is done, and I'll highlight sort of essentially how manual this process is. And as if this is the sort of data that's key to unlocking AI, sort of shows you some of the challenges it faces. But In this case, what you'll find is when they're trying to monitor spoil at each gate, and there's typically a number of gates on a construction site, there's a traffic controller that sort of monitors traffic and controls traffic coming in and out, and there's also a gatekeeper. And the gatekeeper's job is to record the movements in and out of the gate. And so what they record, there's a couple of pictures on screen. The person in the middle is essentially recording. They record the registration plate. Essentially, they write that down on the image on the right there on the screen. The time the truck comes in, the time the truck goes out, the type of fill, i.e. it's sort of whether it's contaminated or clean fill, the dump site it's likely to go to, and the gate that it entered and leaves through. And all this is done with pen and paper at the moment. And at the end of each shift, someone takes a photo of the piece of paper that they've jotted all this information down of, then sends that via WhatsApp or email, and it's then transcribed and put into Excel. So what you can see there is, sorry, I skipped ahead a couple of slides. What you can see there is that there is a large number of manual processes involved in each of these. It's incredibly inefficient. It exposes people to safety risks, but it's obviously prone to lots of human error. So we thought, obviously, there must be a better way to collect this data in a generalized fashion. You should be able to do it hopefully in real time, which will show some examples where we have. That's more reliable, less prone to error, but also serves as a rich record of activity both now and into the future. And that obviously is the use of computer vision and AI, which allows you to collect this information simultaneously. And I'll touch on two initiatives, only very briefly, where we've used this to look at productivity, but also via the tracking of materials, or via the using materials almost as a proxy in many of the cases. And the first initiative I'll touch on is which is the CICT pilot, which is the Construction Industry Cultural Task Force pilot, which looked at productivity at Brunt Road. That's with one of our alliances. And this CICT pilot was focused on looking at the productivity changes associated with moving from a 5.5-day work week to a 6-day work week. So for those who aren't familiar, the construction sector typically operates on a 5.5-day work week with a fortnightly RDO. And this initiative involves, for wellbeing purposes, was to look at how could we have people work a 5-day work week, slightly longer hours, but have more time off on weekends. And in this instance, we were looking at a road over solution. So we looked at the reinforced earth wall panels as a proxy measure for how they're installed and some of the activities associated with them for measuring productivity. I'll now play a short video, or I will in a moment, but we obviously looked, in this case, we partnered with obviously our alliance partner, the Metropolitan Roads Program Alliance, or MRPA, and a New Zealand-based company called Timescapes, who have taken sort of time-lapse photography beyond just images, and they've really expanded on what it can be used. And in this next little video that I'll play, the images that are captured are every 5 minutes. So hopefully this video is all playing for everyone in the audience, but it's a little bit self-explanatory, but I'll give some commentary over the top just to make a bit more sense of what's happening. So this Timescapes tool allows you to put a BIM, or building information model overlay, so you can look at where panels are supposed to be installed. You can zoom in and out. It obviously does your standard time-lapse photography, but allows those BIM models to be overlaid, so you can see where materials are supposed to be, or where panels are supposed to be installed. You can actually have a look at how that progresses. But what it does beyond that is it actually pulls out analytics from this imagery, and that's what really sets it apart. So in this case, it's counting the number of people that are working near where those cameras, we had 4 cameras located near where the reinforced earth wall was being constructed in the lead up to the bridge. Similarly, you can look at excavation activity. So you can, what's more, create heat maps of the lot of that sort of activity in a time-lapse animation. Similarly, you can look at concrete pours. So you can look at a concrete pour, you can create a heat map, but you also get an idea of how often and therefore how much of materials are being delivered and moved around. And what's more, obviously, you can assess also the impacts of weather and the like on site. So obviously when it rains, activity stops, and you get a much better handle on what that looks like and what impact that has on timelines and schedules. This time lapse was obviously solution was very low cost. It was easy to set up, and it provided significant benefits. But beyond looking at just, and as we're looking at in the video I showed was tracking installed panels, you can also look at other things. For example, you can look at waste materials. In this case, it's highlighting where there's sort of skip bins on site, and it can flag when those need to be empty, but you can also start recording how often they need to be emptied, so you can actually have a look at how often waste material or how much waste material is being generated on a site that would typically go into one of those skip bins. The second example that I'll touch on was an initiative that we looked at for metrics associated with earthworks. So as I sort of touched on before about the spoil tracking process and how that's monitored, that's very inefficient. So we worked together with the site teams to try and find a better way where this could be done using cameras. However, unlike in the last example where we use time-lapse imagery, because we're looking at a more granular sort of information, we had continuously recorded, we use continuous recorded data in this example. Again, we worked together with partners. In this case, we worked together with the Building 4.0 CRC, which is a cooperative research centre or federally funded research centre. We worked with Site Data, who was sort of the computer vision expert, and with the University of Melbourne, and with our partner, the SEPA, or the Southeast Program Alliance. Everyone in this case there was some particular focus on ensuring that we maintain privacy, and so we obscured people, and as you'll see in some images in a minute there, actually converted into sort of yellow blobs, and we're working together with Melbourne Uni to see first to do some accuracy assessments from this, but also to highlight some of the privacy challenges of how we can work through some of those. And I'll now touch on a little bit of some of the results. We did obviously work together with SEPA and had some discussions with the unions on site to ensure that we could proceed with this monitoring and this study. So typically, what have we got? Well, we had cameras installed on site, the typical security cameras installed around site. This was at Dublin Road in East Ringwood, where you actually had a trench installed. So some of the cameras were installed on the edge of the trench. Otherwise, they were typically installed on poles. Again, this lets you sort of classify and pull out various things on site around types of excavators, etc. Again, this one just shows a sample video. Again, we're looking at tracking the amount of spoil that was being removed. So in this case, on the video, what we're doing is every time in the excavator in the back, the bucket goes above the truck. We're counting the number of times that bucket goes above the truck, and therefore we're getting an estimate of the amount of material being removed per truck. And obviously, we can also count the number of trucks, so we actually get an estimate of the amount of material being moved across time. And as you can see in these images, the people are converted into sort of yellow blobs to make sure that they're not personally identifiable. We can also pull on, conscious of the time, I'll also pull out certain information relating to monitoring registration plate, which helps you also look at where trucks are coming in and out. You can start to get an idea of what the type of the truck is, because you can look up that vehicle in the National Heavy Vehicles Register, and then you can look at your emissions profile as well of the vehicles that are working on site when you couple that with the trace of where those trucks are travelling from and to. Also has a load of benefits in safety. You know, the image on the top with the lots of red lines and the black lines. The black lines show where the vehicles go. The red lines show where people have walked, and you can actually start to see where there's interaction. So it could be, or where there's potential interactions. Similarly, where loads are covered, you can actually have a look at where some of that, you might get spillage from the back of trucks in there as well. Key takeaways, we see computer vision and AI is offering a significant return on investment. It's real-time and multi-purpose, so you can draw lots of insights from the same set of footage. And obviously, as AI is sort of the power of AI is expanding, it's low cost and mature technology, and you'll be able to get more and more information out from that footage all the time. And we think it can serve as a valuable tool in tracking the movement of materials to and from site. And with that, I'll say thank you, and I guess we hand over to the questions or to the panel discussion.
Amazing. Thanks so much for that, Paul. And I'll invite Patrick and Ilott to join us as well. And I want to kick off with a question, and maybe Paul, if you stop here and share your screen, hopefully all four of us can appear in a quadrant that looked very much like the one Patrick had up earlier. I'm not sure who's in the top right corner. Doesn't really matter. Paul, let's talk technology and people juxtaposition. And I say that against the backdrop of, it's great, you have cameras on site, it's recording the movement of people, plant, materials, and so on. But it's also recording productivity. And just off the top of my head, I wonder if there might be some sensitivities associated with that. And that's coming from me. It's a broader question. Tell me about the journey in terms of the attitudes of people towards the use of the technology.
Yes, look, there needs to be obviously you make an effort to communicate with everyone. That's a key. There's a communications exercise. I think most people are probably not, when they understand what you're trying to do and how it has the opportunity to transform how people work. I think there is an understanding that you're not looking at individuals and you're not monitoring individuals. You're looking at sort of bulk activities that need to be monitored anyway. That's part of monitoring a contract. You need to sort of do that anyway. So I think that once you sort of explain and you go through the exercise of reaching out and explaining that to everyone, is generally a better understanding. Of course, there's always learnings that you have of how you may be better at doing that, how you may engage with those teams early enough, and how you might sort of set out that and embark on that communication sort of exercise, but it is a core part of it. And when people understand what it's being used for, they generally don't have a problem with it. It's when they don't understand that they sort of can draw some draw some inaccurate conclusions.
Thanks for that, Paul. It sounds to me like the change management piece is just as important, maybe even more important than the actual technology or widget.
Yes, yep, definitely.
And I see, Ella, you're nodding your head there, and I want to bring you into the conversation, and because I have a different question I want to ask Patrick. But Ella, I want to pose a similar question to you based on what we saw in your presentation. And you had some case studies from different parts of the world. We talked about technology adoption in various countries and so on. But let's talk about people and their attitudes. What has been your experience?
Look, I agree with Paul. I think the change management piece is such a large piece of the puzzle for successful tech adoption. I think when it comes to material tracking, we're often implementing technology on a construction site with previously manual processes. Paul did a great job of showing how manual these processes can be. So I think it's imperative that the tech that we're introducing doesn't add an extra step to the process and actually simplifies it. And you have to aim for the technology to make it easier for the person on site than writing down in a book, like Paul explained. So I think it's really important that it's as simple as possible, which is why one of the technologies I talked about, Qflow, I think that's why that technology is so successful at being adopted, because it just requires snapping a photo and then on site, and then the tech does the work of passing that photo and extracting the data.
Excellent. Thanks for that. I think that what I'm also hearing is that maybe independent of the sectors or the countries or the cultures, there's still that importance of change management and a recognition that technology isn't the be all and end all, that the people are important as well. And maybe it's a good segue before I jump to the questions in the chat. I want to get through as many as possible. Actually, you know, Patrick, I want to ask you a question that has come from the audience instead of one of my own. And I can see here it comes from Stephanie Clark. Thank you so much for your question, Stephanie. Loved your carbon circularity matrix. Have you many clients talking on this type of quantification? Are there specific compliance requirements, I guess, to incentivize measuring circularity?
Well, thanks for the question. No, not many clients. You know, there's a lot of clients making commitments and policies and the like to both topics, to circularity and to carbon. And there is an assumption out there that you can't necessarily have wins in relation to both. The few clients I have been engaged for, what we've learned in the process of doing these comparisons is that it is possible to realize wins for carbon and circularity simultaneously, but it's not always the case. A classic example is recycled sand or recycled rocks or reused rocks have a higher carbon footprint often than virgin sand. However, in that kind of example, the sand is not a particularly big contributor to the overall carbon footprint, and you could park it actually, and you should focus on circularity for it. And we get that kind of intelligence out of this kind of process. Now, I hope I haven't gone off on a tangent there in relation to the question, but that's what occurred to me when you framed the question there, Reza.
That's fine. Thanks for providing that additional context there, Patrick. Now, Ella, there are multiple questions. So I'm just sort of going to ask you both, and you can address both. And one is around the cost for using the material tracking technologies, keeping in mind that local councils and maybe all clients in general are all about the cost and savings. So one is about the cost, if you can give us an idea of the cost. And another one, so thank you, Goran. Another one comes from Victoria, and it's congratulations on achieving a 99% reduction in carbon emissions, an impressive result. With the internal incentives and self-imposed carbon tax impacting team performance metrics, how does this align with external reporting? Are the results reflected similarly, or are they reported differently? Over to you, Ella. Go.
Thank you. So first up for costs, typically the cost for these platforms is charged based on the size of the project. They typically use a SaaS or software as a service model. And the cost can vary a lot. It really depends on the size of the project. What I would say is that for local councils, I would really recommend trying to take advantage. There should be like tiered pricing. They probably shouldn't be charging a government client the same as what they're charging a commercial office developer client. So I would try to check that you're on kind of preferential pricing. And if not, the tech startups might hate me for saying this, but I think with a SaaS model, things are often negotiable. I would also suggest often the benefits of these technologies apply to the project owner, but also the contractor as well. So it might be worth talking to the contractor that you're working with and see if you can maybe share the cost as well or collaborate on the project. So I'd recommend that too. And then in terms of the second question, how does GPE report on sustainability metrics and carbon with the carbon tax? So it doesn't really make a difference to the external reporting. I would say that because the internal carbon tax is a big part of the roadmap to net zero, it's big in terms of explaining the strategy externally and also being a thought leader in the space. But when it comes to reporting the embodied carbon in a building, it is related to the actual materials that are used. But you can check out more about that. They have a great sustainability report and a wonderful team who put that together. So I'd recommend reading more about that there.
Excellent. Thanks so much for that, Ella. Now, I want to take the panel future looking, because I'm also conscious of the time. And it's a question around, and Paul, you could go first, and then we'll go Patrick and Ella before I hand back over to Vesna to take us home. And the question is, when we convene this panel in 2030, what's your hope and your dreams for the status of materials tracking by then?
I'd like to hope that it all happens automatically and seamlessly.
Great, and with broader adoption, I suppose, as well.
Yeah, and it would be mandatory everywhere. So
amazing. I share your dream. Thank you, Paul. Patrick?
Oh, I'd like the labeling on products, whether they're a rock or a project, to be akin to our food labeling. We have really transparent numbers on those key things: inflows, outflows, energy, water, economic impact, and that also the numbers are all maxed out. The numbers are all great. So yeah, that's what I'd like, and we can build them into models.
Amazing, thank you, because it's already part of the way we operate and we're accustomed to it. So why can't we expect it more broadly in materials tracking? Yeah, thanks for that, Patrick. Ella?
Yeah, I love that comparison, Patrick. Yeah, I think for me, just similar to Paul, material tracking is given and is the norm rather than the exception, and we can actually get on with a significant more portion of reused materials rather than using so many new materials.
That's great. Thanks. I like the way that you brought the sustainability lens as well. Yeah, very well done. So thank you on behalf of everyone who's joined us. Thank you all for taking time away from your day to join us. We hope that it was insightful. I want to thank the panelists, and don't go yet because I do want to hand you over to Vesna. So if you are at home, please join me in giving Paul, Patrick, and Ella a virtual round of applause. Thank you. And you do have their contact details. I'm not sure if we're going to be sharing the slide decks as well. So please do reach out to them and reach out to us. Over to you, Vesna.
Thanks so much, Reza, for moderating this session today. And a big thank you to all our panelists, Ella, Paul, Patrick. We appreciate your time and valuable insights. Also, thank you to everyone online for joining us today. We do have some upcoming sessions for the remainder of Greener Infrastructure Week. Tomorrow at 3:30 p.m. we have a webinar called Delivering a Green Legacy, Lessons from Home and Abroad. And on Friday at 10 a.m. There is a session called Circular Economy Transition, how the Victorian government is supporting for success. So if any of these sessions spark your interest, please ensure to register through the website or by scanning the QR code. Once again, thank you everyone for joining today, and enjoy the rest of your week.
Thanks, everyone. Bye.
Bye-bye.